The public rise of light, the era of neon and fluorescent illumination. Even before electric lighting had fully penetrated homes, the public spaces of cities were increasingly bathed in artificial light. The first half of the 20th century marked a period when illumination emerged not only as a technological advancement, but also as a social and cultural instrument. In particular, neon and fluorescent lighting transformed cities, making them not only visible, but also symbols of modernity, advertising, and aesthetic appeal. The story of neon light began in 1898, when English chemists William Ramsay and Morris Travers discovered the element neon. In 1910, French inventor Georges Claude excited neon gas with electricity, producing a bright reddish glow. Claude enclosed the gas in glass tubes, creating a formidable, highly visible light source. The first neon signs were born. The first commercial neon advertisement appeared in 1912 in the window of a barber shop in Paris. However, the real boom occurred in the 1920s and 1930s in the United States, as cities like Broadway and Las Vegas were adorned with neon lights. This new type of illumination became more than just a tool for advertising products. It became an emblem of an era. Fluorescent lighting, on the other hand, had a different technological foundation. Fluorescence relies on a substance absorbing light and emitting it at a different wavelength. Developed in the 1930s, fluorescent lamps produce visible light by electrically exciting a gas to emit ultraviolet light, which then strikes a phosphor coating on the lamp's interior. Compared to incandescent bulbs, fluorescent lights consume less energy, emit less heat, and last longer. These qualities led to their rapid adoption in public buildings, schools, hospitals, and industrial facilities. These lighting technologies were not only technical innovations, but also reshaped urban aesthetics and social perception. Neon lights redefined the nighttime city skyline, while fluorescent lighting became a functional tool of daily life. On one side, neon conveyed excitement and attraction. On the other, fluorescent light symbolized discipline and efficiency. Light was no longer merely a matter of visibility. It became a language of emotional atmosphere and social order. From the mid-20th century onward, evolving urban planning emphasized that public spaces should be safer, more orderly, and more functional. In this context, lighting became not only a matter of security but also a form of social control. Streets, squares, bridges, and tunnels were no longer defined solely by architecture. Light itself became an integral component. The modern city emerged as a product not only of structures but also of networks of illumination. In conclusion, the rise of neon and fluorescent lighting demonstrated that electricity was more than energy. It was a narrative, an aesthetic, and a tool of power. Public spaces transformed under the glow of technology, and human behavior began to adapt to the rhythms set by this new light. LED technology, the revolution of efficiency and color. The final quarter of the 20th century witnessed a quiet yet profound revolution in lighting. LED, light-emitting diode, technology fundamentally transformed the nature of light, its applications, and aesthetic perception. Initially developed in 1962 as an electronic component capable of producing red light, LEDs were used primarily in electronic displays. However, over the following decades, the discovery of blue LEDs and the synthesis of white light propelled this small semiconductor to the forefront of the global lighting market. At the core of the LED's revolutionary impact was energy efficiency. Traditional incandescent bulbs convert a large portion of energy into heat, whereas LEDs produce the same amount of light with significantly less energy. This feature attracted not only household consumers, but also urban planners, industrial designers, and sustainability-focused policymakers. With lifespans exceeding 25,000 hours, LED lamps reduced maintenance costs, minimized carbon footprints, and became integral to global energy strategies. Yet, the influence of LEDs extended far beyond energy savings. Their color versatility and design flexibility made them an indispensable element of contemporary aesthetics. Capable of emitting light across different wavelengths, LEDs could generate millions of color tones through RGB combinations. This capability enhanced the visual expressive power of lighting in contexts ranging from stage performances to automotive headlights, from architectural facade illumination to television displays. LED signs in city centers conveyed not only information, but also became part of urban identity. The modular and slim structure of LEDs opened new design possibilities. Beyond the traditional bulb shape, light sources could now integrate with surfaces, bend, and be digitally controlled. In smart home systems, LEDs evolved into platforms that adjust according to the user's mood, the time of day, or the function of a space. Light became not static, but programmable media. The transformation extended to public spaces as well. In large-scale applications such as traffic lights, street lighting, tunnels, and parking areas, LED technology not only reduced energy consumption, but also provided clearer visibility, lower maintenance, and safer environments. This shift reshaped the nighttime face of cities while offering long-term economic advantages to municipalities. In conclusion, LED is more than a new light source. It is a technology that has redefined illumination itself. One of the greatest leaps since the widespread adoption of electricity, the LED revolution has transformed not only physical environments, but also cultural, economic, and social practices. This evolution demonstrates that light now exists not merely to be seen, but to generate meaning. The future of light, biophotonics, laser, and quantum illumination. Light has illuminated human vision for millennia. Today, however, it has become a tool that reads our bodies, carries data, and controls machines. At the intersection of modern science and engineering, light technologies are no longer just for illumination. They occupy a central role in diagnostics, communication, computation, and control. Biophotonics. Journeying inside the body with light. Biophotonics studies the interaction of light with living tissues and has revolutionized the field of medicine. One of its most well-known applications is laser eye surgery, LASIK, which has corrected vision for millions, yet this is only the beginning. Optical coherence, tomography, OCT, enables detailed imaging of the retina and blood vessel walls. Operating with micrometer-level precision, OCT has become standard in early diagnosis of eye diseases. Laser cancer screening systems. Lasers penetrate tissue to detect abnormal cellular structures, allowing non-invasive cancer screenings. These methods are faster and carry less risk than traditional biopsies. Fluorescent cell imaging. Special dyes injected into living cells are illuminated with light, allowing observation of cell division, protein interactions, and other complex biological processes in real time. Biophotonics is shaping the future of medicine not only in diagnostics, but also in light-mediated drug delivery and cell-level therapies. Laser technologies. Focused, light-driving new industries, laser. Light amplification by stimulated emission of radiation produces highly directed, intense light at a single frequency. Since its invention in the 1960s, lasers have transformed industries from science to manufacturing. Precision cutting and welding. Laser cutting enables micron-level accuracy in automotive, electronics, and aerospace industries. Laser welding joins metals without direct contact, reducing deformation risk. Microchip and semiconductor. Fabrication. Lasers etch nanometer-scale patterns on semiconductor wafers, enabling the creation of modern integrated circuits, the brains of today's computers. 3D laser printing. Additive manufacturing. Metal powders are melted layer by layer with lasers to produce solid components, from spacecraft parts to prosthetics. Fiber optic communication. Laser pulses transmit data through thin glass fibers, allowing terabytes per second to be transferred with minimal loss. The foundation of today's high-speed internet relies directly on laser technology. Quantum illumination and photonic systems, a new age of information. Photonic systems use light rather than electricity to carry information. They form the basis for quantum computers and optical circuits. Photon-based computing. Photons generate far less heat and move faster than electrons, potentially serving as processors in future microchips. This overcomes the speed and energy limitations of classical electronics. Quantum encryption, quantum key distribution. Single photons sent via lasers ensure unbreakable data security. Quantum rules dictate that measuring a photon alters it, revealing any eavesdropping. Quantum illumination. Using entangled photon pairs, clear images can be obtained even in low-light conditions, with applications in radar and military technology. Photonic logic circuits. Research focuses on optical CPUs, potentially enabling artificial intelligence infrastructures operating at the speed of light. Next-generation lighting. Smart, efficient, interactive. Light sources are now more than mere lamps. They are part of an ecosystem. Micro-LED and OLED technologies consume less energy than traditional incandescent or fluorescent bulbs and last longer. Flexible OLEDs enable bendable screens, decorative lighting, and wearable tech. Smart lighting systems, lamps that adjust to ambient light and respond to motion sensors, are becoming standard. Integrated with the Internet of Things, IoT, they contribute to home automation. Light-based communication, Li-Fi. LEDs transmit data by flickering thousands of times per second, offering an alternative to Wi-Fi. Li-Fi is advantageous in environments sensitive to electromagnetic interference, such as hospitals and airplanes. Light now speaks not only to the eye, but also to the mind, data systems, health, and the future. Biophotonics reads the body. Laser technologies transform industry. Photonic systems design the future of information. Smart lighting reshapes cities. This multifaceted transformation of light is not only a technological revolution, but also an evolution in how humanity perceives, thinks, and interacts. Knowledge, energy, and influence are now conveyed by a beam of light. The future of light. Biophotonics, laser, and quantum illumination. Light is no longer merely a tool for vision. It has become a carrier of scientific discovery, technological revolutions, and the information age. The light technologies of the future illuminate not just streets, but cells, data flows, and even computing infrastructures. Biophotonics, the discipline studying the interaction of light with living tissues, is redefining the boundaries of modern medicine. Imaging methods such as optical coherence tomography, OCT, can non-invasively scan the interior of blood vessels. Laser-assisted biopsies are revolutionizing the early detection of cancerous cells. Eye treatments using lasers, such as LASIK, allow personalized correction of vision disorders. These light-based interventions at the cellular level open doors to more precise, faster, and less risky methods in both diagnosis and treatment. Meanwhile, laser technologies are transforming not only medicine, but also industry. From microchip production to 3D printing, from precision metal cutting and welding to laser-based wireless communication systems, concentrated light power is employed across numerous fields. These technologies do more than improve efficiency. They enable higher output with less energy. Quantum light systems, though still in early stages, promise groundbreaking innovations in data security and transmission. Quantum cryptography makes communication via photons virtually unbreakable. Photon-based quantum computers have the potential to process massive data sets at the speed of light, surpassing the limits of classical computing. In the future, fully light-powered computers with minimal energy consumption could become a reality. Finally, next-generation lighting technologies have become a cornerstone of smart cities. Micro-LED and OLED panels offer energy efficiency while providing virtually limitless aesthetic possibilities. Sensor-based systems have been developed for street lights, office lighting, and home systems that adjust to ambient light and human activity. Light no longer merely illuminates our surroundings. It interacts, responds, and learns. Light-powered devices, integrated with the Internet of Things (IoT), help create environmentally conscious, energy-efficient, and data-driven living environments. The light of the future is becoming a source of knowledge that reveals more than what is visible and helps us understand the invisible. Data that cannot be seen with the naked eye becomes readable through light. Light no longer only illuminates darkness, it illuminates the unknown. Today, we have witnessed not just the story of a single technology, but the journey of humanity's relationship with the darkness of night. From the first spark of fire to oil lamps, from the sacred flames of candles to the vitality brought to cities by gas lamps, from Edison's light bulb to LEDs and the frontiers of quantum illumination, this journey is, in essence, a part of humanity's own story of existence. Throughout history, light has existed not only for seeing, but for thinking, believing, creating, and feeling. With it, cultures were born, cities took shape, and science progressed. Every new source of light illuminated not just the night, but our minds as well. Today, lasers transmitting billions of data points per second through fiber optic cables, biophotonic devices scanning our cells, and quantum illumination reaching toward the deepest secrets of the universe are all part of this legacy. Yet behind all these advancements lies an unchanging truth. Humanity finds its path by following the light. Perhaps this is why, within every lamp, every flame, every beam of light, the same message is hidden. Darkness is never absolute. When humans carry their light with them, they illuminate both the night and the future.